Reflection of sound. Propagation of sound depends upon the composition of the medium, but the nature of the sound also plays an important role. Different frequencies can move. In particular, sound waves are characterized by the generic properties of waves, such as wavelength, frequency, amplitude, and speed of the wave. Look at this graphical representation of a sound wave that shows how density and pressure change when the sound wave moves in the medium. The density as well as the pressure of the medium at a given time varies with the distance above and below of their respective average values. Since the compressions are the regions where the pressure as well as the density is more than their normal values, such regions are represented by the upper portion of the curve, and the peak represents the region of maximum compression. Whereas the rarefactions are the region where the pressure as well as the density is less than their normal values. Such regions are represented by the lower portion of the curve. A peak is called crest and a valley is called trough of the wave. Minimum value of the pressure or the density on either side of the normal value is called the amplitude of the wave. It can also be defined as the maximum displacement of a layer of air from its mean position when the sound waves propagate through the air. It is usually represented by letter A. SI unit of amplitude depends on the quantity in terms of which the amplitude is being described. For example, if the amplitude is described in terms of pressure, then its unit is Newton per meter square. And if it is described in terms of density, then its unit is kg per meter cube. And if it is described in terms of displacement, the unit is meter. In general, distance between two consecutive centers of crests or two consecutive centers of troughs of the wave is called the wavelength. It is the minimum distance after which the pattern of the motion repeats itself. It is usually represented by the Greek letter lambda. Since it is the measure of the distance, therefore its SI unit is meter. In case of sound waves, that is, the longitudinal waves, the wavelength can also be defined as the distance between the center of two consecutive compressions or two consecutive rarefactions. Frequency tells us how frequently a wave passes through a point. Suppose you are beating a drum. How many times you're beating the drum per unit time is called the frequency of beating the drum. We know that when sound propagates through a medium, the density of the medium varies between a maximum and a minimum value. The change in the density from a maximum to the minimum value, again to the maximum value, makes one complete wave. The number of such wave cycles crossing a given point of the medium per unit time is the frequency of the sound wave. In other words, if we can count the number of the compressions or rarefactions that are crossing the given point in 1 second, we will get the frequency of the sound wave. It is usually represented by Greek letter nu, and its unit is waves per second or cycles per second. On the other hand, the minimum time after which the pattern of the motion repeats itself is called time period of the wave. It is simply the time taken to produce one wave. So, the time period can also be defined as the time required by the wave to travel a distance equal to its wavelength. It is represented by letter T and its unit is second. Frequency of a wave is related to the time period of the wave as both are reciprocal of each other. Since the SI unit of time period is second, hence the frequency can also be measured as per second, which is also called hertz. If the time period of a wave is 5 seconds, it means it takes 5 seconds for the wave to complete one cycle. Then the frequency of 0.2 Hz. That is, the wave completes 0.2 cycles every second. In the similar way, if the frequency of a wave is 20 Hz, then the time period of the wave is 0.05 seconds. Another important characteristic of sound waves is the speed of sound, also known as sonic speed. For a wave speed refers to how fast a wave travels. Since the wave is a traveling disturbance, therefore, speed with which a disturbance travels in a medium is called its wave speed, or the speed with which the compression and the rarefaction of the wave moves along. Here, it should be kept in mind that the wave frequency refers to the number of cycles crossing a point in 1 second. But wave speed refers to the distance travelled in 1 second. Mathematically, the wave speed of a wave is the distance covered by the wave in 1 second. It is represented by the letter V. The time required for covering the distance of one wavelength is the same as the time period. So, the relation for the wave speed comes out to be lambda upon t. As the frequency of a wave is reciprocal of the time period of the wave, the relation for wave speed becomes equal to the product of frequency and wavelength of the wave. SI unit of wave speed is same as of speed, that is meter per second. If a wave moves a distance of 20 meters in 5 seconds, then the speed of the wave is 4 meters per second. Sound propagates through a medium at a finite speed. In general, the speed of sound depends on some properties such as density, pressure, and temperature of the medium. It has been observed that the speed of sound decreases when we go from solid to gaseous state. In any medium, as we increase the temperature, the speed of sound also increases. For example, the speed of sound in air is 331 meters per second at 0 degrees Celsius, 344 meters per second at 22 degrees Celsius. Light sound also gets reflected at the surface of a liquid or solid. When a sound wave travels in a given medium, it strikes the surface of another medium and bounces back. This phenomenon is called the reflection of sound. The waves are called the incident and reflected sound waves. The sound wave that travels towards the reflecting surface is called the incident sound wave. The sound wave bouncing back from the reflecting surface is called reflected sound wave. And the point of incidence and the point of reflection are the same point on the reflecting surface. A perpendicular drawn on the point of incidence is called the normal. Similar to light wave, the angle which the incident sound wave makes with the normal is called the angle of incidence, and the angle which the reflected sound wave makes with the normal is called the angle of reflection. Sound waves also follow the same laws as in case of the light. Laws of reflection. The incident wave, the normal to the reflecting surface, and the reflected wave at the point of incidence, all the three lie in the same plane. The angle of incidence is equal to the angle of reflection. An obstacle of large size is required for reflection of sound waves. For more clarity, let us see an activity. Let's take two identical hollow pipes of sufficiently large and equal length. Arrange them on a table near a wooden board as shown. Place an alarm clock near the open end of one of the pipes and try to hear the sound of the clock through the other pipe. For an incident sound, the corresponding reflected sound can be heard if we place our ear exactly in the direction of an angle equal to the angle of incidence. If we displace the pipe, the sound is not heard. Furthermore, if a sound-absorbing material is placed at the correct angle of reflection, again the sound is not heard as it is absorbed. Similar to the focusing of light rays with a concave mirror, sound waves can also be focused by concave surfaces. Let's arrange two concave surfaces opposite to each other. If a source of sound is placed at one focus, the sound produced by the source can clearly be heard by a listener only if he is at the other focus. Phenomenon of reflection of sound is used in many devices like megaphones, soundboards, hearing aids, and stethoscopes. Megaphone. Megaphone is a horn-shaped tube. The sound waves are prevented from spreading out by successive reflections and are confined to the air within the tube. Hearing aid is commonly used by the people who are hard of hearing. Sound waves received by the hearing aid are reflected into a narrower area leading to the ear, by virtue of which the hearing capacity of the person is enhanced. Soundboards. Soundboards are curved surfaces that can reflect sound waves. This reflection of sound waves is used in auditorium that makes the sound to reach every corner of the room. Reflection of sound waves is done by using soundboards by locating the speaker at the focus of the soundboard. Stethoscope. Stethoscope is used by the doctors to listen the sounds produced within the patient's body, mainly by the heart or lungs. The sound produced by the heart reaches to the doctor's ear after multiple reflections within the tube of the stethoscope. The rolling of thunder is also due to successive reflections of the sound from a number of reflecting surfaces, such as the clouds and the land. Sound reflection is also seen as echoes. If a sound is made to reflect from a surface, it is heard back as a second sound, which is an exact replica of the first. This second sound is termed as an echo. Our ears cannot distinguish sounds heard within a gap of 1/10 of a second. To hear a distinct echo, the time interval between original sound and the reflected one must be at least 0.1 second. If we take the speed of sound in air to be 344 meters per second at a normal temperature, the sound must go to the obstacle and reach back to the ear of the listener on reflection after 0.1 second. Hence, the total distance covered by the sound from the point of generation to the reflecting surface and back should be at least 34.4 meters. Thus, for hearing distinct echoes, the minimum distance of the obstacle from the source of sound must be half of this distance, that is, 17.2 meters. Though echoes may be heard more than once due to successive or multiple reflections. Similar to the echo, there is one more phenomena, which is also due to reflection of a sound called reverberation. A reverberation is perceived when the reflected sound wave reaches to our ears in less than 0.1 second after the original sound wave. Since within this time gap, the original sound wave still retains in our memory, So, there is no time delay between the perception of the reflected sound wave and the original sound wave. The two sound waves tend to combine as a very prolonged sound wave. In a concert hall, sound produced at the stage arrives to the listener through different paths. Thereby, they take different time to reach the listener. If the waves of the same sound arrive after a distinct interval, it becomes disturbing as it mixes with the second sound. That is why certain sound-absorbing materials like compressed fiberboard or rough plasters are used in the ceiling and walls of the hall judiciously to avoid unwanted reflection of the sound.